Welcome again to Let's Talk Advanced Chemistry, Chemistry 2 with Pastor Dan. We're going to look at a concept called where K sub C is less than 10 to the minus fifth. Now, we did this last year, so this is going to be review. If you want additional, you can go back into Chem 1. We talked about solutions and equilibrium at the end. We did these, but I'm going to go through this again before we get the step up in the next section. So, let's take a look at the problem. Determine the concentration of all elements and compounds at equilibrium for the Haber reaction. If at 25-degree reaction starts with, that was Haber, sorry, 1.255 molar hydrogen, 2.000 molar nitrogen, when the equilibrium product constant is 2.876 times 10 to the minus seventh. Now, first thing we're going to do is take the reaction. That's Haber reaction balance. Now, if you remember from last year, and if you don't, we'll just go over it again. We'll take three sets of conditions. The first is start. The second is reaction. And the last is equilibrium. So what conditions are we starting with? Well, from the problem we see that we have 2.000 molar nitrogen and 1.255 molar hydrogen. And we don't have any ammonia to start with because it's a product. Products are formed, we start with reactions. Now, when we do the reaction, we're going to lose X because of molar relationship here. I have only 1 molar, so therefore I'm going to lose a value. We don't know how much that is, so we call that X. We're going to lose 3X of hydrogen, and then we're going to gain 2X of ammonia. Now, when we take and add those up then, bring everything straight down, we're going to get 2.000 minus X for nitrogen, 1.255 minus 3X for hydrogen, and 2X for K for ammonia. Now, we take our KC equation, and we take our products over reactants, and raise our coefficients to their exponents. So this is going to be ammonia squared divided by nitrogen and hydrogen cubed. Okay, so put our values in for KC. We're going to get nitrogen, which is 2X squared. And we're going to use 2.000 minus X and 1.255 minus 3X cubed. Now, because of this value here being 10 to the minus seventh, being such a small value, we can take and get rid of those X's, just make it easier to work with. And that's going to be equal to our KC value, 2.876 times 10 to the minus seventh. Now it's just algebra from here. First thing we're going to do is square 2x. So 2x times 2x is 2x squared. Now we're going to multiply up to get rid of that fraction. So 4x, that's 4x squared. Squared is equal to 2.876 times 10 to the minus seventh times 2.000 times 1.22255 cubed. And then to solve for x, we're going to divide both sides by 4 and then take the square root. So take your calculator, 2.876 EE minus 7 times 2.000 times 1.255 cubed equal, divided by 4, equal square root of the answer, equal, and our answer for x is 5.331 times 10 to the minus fourth. Now, that's not my answer yet. I got to go back into each of these values to get what we want. So, for nitrogen we said was 2.000 minus X. So 2.000 minus 5.331 times 10 to the minus 4. Remember, last field column for subtraction. We're going to get 1.999 molar. Not much of a change. For hydrogen, we're going to take 1.255 minus 3x, so 1.255 minus the parentheses, 3 times 5.331 EE minus 4, close parentheses. When we do that, we get an answer of 1.253 molar. Again, not much of a change. For ammonia, then, it's 2x, so 2 times 5.331 times 10 to the minus fourth is going to be 1.066 times 10 to the minus third molar. All right, those are answer that one. Hopefully that's not too bad. Let's try another one. Okay, calculate the concentration of all reactants and products, reaction of copper-2 nitrate and aluminum sulfate. If each reactant is 3.55 molar, to start with a KC value of 3.2787 times 10 to the minus 6th. All right, so those are reactants, copper-2 nitrate, aluminum sulfate, and this is equilibrium. Remember, there's double replacement, so copper is going to go with sulfate, aluminum is going to go with nitrate. Oxidation numbers balanced up. There we go. Make it smaller so we can work through it. So we start, react, equilibrium. RT 3.5550, 3.550, and 0 for each of those. We're going to lose 3x. We're going to lose x. We're going to gain 3x. We're going to gain 2x. At equilibrium then, bring everything down, and that's the values we have. All right, for our KC then, it's going to be copper to sulfate cubed times aluminum nitrate squared all over copper to nitrate cubed and aluminum sulfate to the first power. Put our values in. Copper to sulfate is going to be cubed, and the aluminum nitrate is going to be squared. And each of those, but remember this is still -6, so I can get rid of both of those, make it easier to go. And that's going to equal to 3.2787 times 10 to the -6. All right, so if I take 3x cubed, I get 27x cubed. If I take 2x squared, I get 4x squared. If I multiply those together, 27 times 4, and put the rest of the values in there, I get 108, multiplying together, and x to the third times x to the second. We're going to add the exponents together. We're going to get x to the fifth, multiply up. So we're going to have 3.550 10 to the third times 3.550 times 3.2787 times 10 to the -7th. Divide both sides by 108 and take the fifth root of both sides. When I do that, I get an x value of 0.002196. Put those back in. So if I take 3.550 minus 3x, I get 3.543 molar. If I take 3.550 minus x, I get 3.548 molar. And if I take and multiply 3 times x and 2 times x, I get 0.006588 molar and 0.004392 molar. Those are our answers. All right, this time, here's going to be a problem. Pause the video, work through this. Any questions, let me know. Remember, ltswpd@gmail.com. Remember, like, subscribe, share. Let people know about it. See if we can help anybody out. I'm going to show all the work here, but I'm not going to pause through it, so you can pause and look at it. Here we go. Okay, so those are our answers right there. So for oxygen, we have 1.45 times 10 minus fifth molar. For CO and Cl2, they're unchanged because it's so small. All right, good. All right, one more. This time I'm just going to give the answers. All right, what is the concentration of all reactants and products for the synthesis of sulfur trioxide? So synthesis, when the concentration of oxygen to start with the reaction is 8.555 molar and the concentration of product is 3.9877 times 10 to the -8. Remember, that's less than -5. Here we go. Ready? Answers. There we go. So that's my x value, my sulfur, and we don't have sulfur there because it is a solid. All right. Hopefully not too bad. Take care. God bless.